When you picture gold, what do you see? You probably imagine a big, glittering nugget, right? Or maybe a sparkling vein of it running through a rock. Well, what if I told you that some of the biggest gold fortunes on Earth are completely invisible, locked away inside rocks that look, well, pretty boring? Today, we are diving deep into the incredible science of how we get that gold out.
See, this is the gold we all know and love. It's the stuff of legends. This is called native gold, and you'll often find it in these beautiful quartz veins. It's right there. You can see it, you can touch it. This is exactly what prospectors dreamed about finding, gold that just screams, "Here I am."
Okay, now look at these two side by side. On the left, you've got that gorgeous, visible gold we were just talking about. But on the right, well, it's just a dull, unremarkable rock. But here's the crazy part. That rock on the right, what's known as a Carlin-type ore, is also absolutely loaded with gold. The catch? The gold is microscopic. It is totally invisible to the naked eye, which, of course, brings up a huge question.
Yeah, how in the world do you get gold out of a rock when you can't even see it? That's the puzzle we're going to solve today, and trust me, the answer is a really fascinating mix of some clever chemistry and some serious engineering.
So it all starts with really understanding the ore itself, the form the gold is in. Whether it's big and sparkly or tiny and trapped, that decides literally everything about how we're going to get it out.
And here's the most important thing you need to know. There are basically two kinds of gold ore. On one side, you have free milling gold. Just think of this as the easy gold. The little gold particles are just kind of hanging out, mixed in with sand or quartz, basically ready to be picked up. But on the other side, you've got refractory gold. This is the difficult stuff. It's microscopic and it's chemically locked inside other minerals, like pyrite. You can't just crush the rock and shake it loose. No way.
All right, let's start with the easy stuff. For that beautiful, visible, free-milling gold, the solution is actually pretty elegant and simple. It's all physical. We just use one of the most basic forces in the universe, gravity.
A perfect example of this is placer gold. You've heard of this. Over thousands, even millions of years, erosion breaks down rocks with gold in them. And since gold is incredibly dense, way heavier than regular rock, those heavy gold particles wash down into riverbeds and settle at the bottom. These are the nuggets and flakes that kicked off the gold rushes.
And we're talking way beyond just a guy with a pan in a river these days. On an industrial scale, this means moving massive amounts of earth, like you see in this open-pit placer mine. The goal is exactly the same, though. Sift through tons and tons of gravel to find those tiny, super heavy particles of gold.
So a modern gravity system is this really cool, multi-step process. First, a trommel screen acts like a giant sifter, sorting everything by size. Then you've got things like jigging and shaking tables that use water and vibration. This lets the really heavy gold sink to the bottom, while all the lighter sand and rock just washes right away. It's just a wonderfully efficient system that uses physics to do all the hard work for us.
But what about that invisible gold, that tough refractory stuff? Gravity is totally useless here. The gold is too tiny and it's locked up tight. To get it out, we have to switch from physics to chemistry. We're going to need a key. Let's get a closer look at the problem. In this Carlin-type ore, the gold particles are less than a micron in size. That is smaller than a single bacterium. And they're trapped inside this mineral cage of pyrite, fool's gold. No amount of simple physical force is going to break that cage open. And that's exactly why just trying to dissolve the gold doesn't really work. If you just pour a chemical like cyanide directly onto this ore, you'll get less than half of the gold out. The chemical just can't get to it. It's still stuck inside that pyrite cage. It's kind of like trying to unlock a door when that door is behind another, bigger locked door.
So, the solution is this really brilliant two-step process. First, you have to break open that mineral cage. This is called pretreatment. You can do it with super intense heat, that's called roasting, or, and this is wild, you can use special microbes that literally eat the sulfide mineral away. That's called biooxidation. Only after that cage is broken can you go to step 2, using the chemical key, like cyanide, to finally dissolve and collect the gold that's now exposed.
And the results? They are just staggering. By doing this two-step dance, the recovery rate for this incredibly difficult ore jumps from less than 50% to over 90%. It's just a fantastic example of how understanding the rock itself lets us figure out these super effective, targeted solutions.
Okay, so let's put this all together. All of this science really builds up to a practical guide. Because at the end of the day, if you know what kind of ore you're dealing with, you know exactly which tool to grab from the toolbox.
It really all boils down to this. If you've got placer gold with those coarse, free particles, gravity separation is your friend. Easy. If you've got visible gold in quartz veins, you crush it up and use cyanide leaching. For that tricky Carlin-type ore with the invisible, locked-in gold, you absolutely need that two-step. Oxidize it first, then hit it with cyanide. See? Every type of ore has its own personality and its own special key to unlock the gold inside.
So where is all of this tech headed? Well, as those easy-to-find, visible gold deposits get harder and harder to come by, the industry is getting way smarter about how to get the invisible gold out, and doing it more efficiently and with less impact on the environment.
We're seeing some really cool trends. For safety, scientists are working on cyanide-free chemicals, basically safer keys, like thiosulfate. For efficiency, companies are using AI and creating virtual digital twins of their plants to perfect the process in real time. To get more bang for their buck, they're figuring out how to pull out other precious metals like platinum at the same time. And way out on the horizon, some lab tests using photocatalytic systems, which use light to drive chemical reactions, are showing insane recovery rates. The innovation here just never stops.
And that kind of leaves us with this one big thought. We started this journey with a simple physical act of sifting visible gold out of a river. We've ended up with complex microbes and chemical keys to unlock invisible gold from solid rock. As we keep pushing the boundaries of what we can do, the real question is how we're going to balance our hunger for this amazing metal with the growing need for smarter, cleaner, and more sustainable ways to get it.